Capacitance of a spherical capacitor. Now, what is a spherical capacitor first? I told y'all, say you have a body and I have given it a charge q. Say the radius of this body is a. Now I bring another conducting body over here. What will happen? Negative charge will be induced in the inner surface of this conducting body whose radius is b, and positive charge will be induced on the outer surface of the body. Now what will this negative charge do? The negative charge will reduce the potential of the inner sphere and the positive will increase the potential of the inner sphere. But what happens? Negative being closer to this body is the potential of the body, but positive being far apart increases the potential. Now we all know Q is equal to CV. Now if here C is Q by V, if V decreases, C will increase. Now this negative charge is reducing the potential of this sphere. Positive is increasing, but negative will reduce more. So the net potential of the inner sphere decreases and capacitance of this combination increases. Now I can increase this capacitance by earthing the outer sphere. This had radius A. This is the outer sphere. Inside is negative charge. I earth the outer sphere. Now what happens? The positive charge is no more because it has been neutralized by the electrons from the earth. But negative charge can't be because the negative charge is bound by the positive charges. So what happens? There is no one to increase my potential of the inner sphere. Only negative will reduce the potential. So my potential gets reduced further and capacitance increases further. This is a spherical capacitor. This is a spherical capacitor. Now how do we get the capacitance of this capacitor? Now to find C, whose potential are we going to find out? This sphere or this sphere? Now you see this sphere is already Earth. The potential of an Earth sphere is 0. So we are going to find out the potential of the inner sphere. Potential is the work done in bringing +1 Coulomb charge from infinity to this point. Now, for a sphere, we know if this has a radius r, inside intensity is 0. For a sphere, inside intensity is 0. So potential is the work done in bringing +1 Coulomb charge from infinity to the sphere. This potential is Q by 4 pi epsilon naught r, where Q is the charge on the sphere. Now when you take the charge to an inner point, somewhere here, for this part, no extra work is done as there is no force. So for a spherical conductor, children, if you draw the graph of potential and distance, if you plot graph of potential and radius, on and inside, potential remains the same. On and inside, potential remains the same. No extra work is done inside. Outside, it varies as 1 by r. So potential of a sphere on and inside is the same. Now you come back to this figure. I want to find the potential of this sphere. Now, due to the potential, due to the charge on its own self is q by 4 pi epsilon naught a. And due to the negative charge, what is the potential here? Now potential on and inside is the same. So what is the potential on the sphere due to this own charge? It's earth, it is 0. Suppose it was not earth, then the potential would have been for a negatively charged sphere. Suppose it was not earth and you had a negative charge, then potential on and inside would have been q by 4 pi epsilon naught b. Due to the negative charge, there is a minus. So for the minus charge, I have q by 4 pi epsilon naught b. For this sphere, on and inside, potential remains the same. Once you get q, your work is done. This is 1 by a minus 1 by b. Once you get v, children, capacitance is done. Capacitance is q by v. Only the thing left is you have to put the value of v over here. Nothing else. So this is q by 4 pi epsilon naught ab by b minus a. Put the value of v, q by q into b minus a, 4 pi epsilon naught ab. Q cancels. So what is your capacitance? 4 pi epsilon naught ab by b minus a.